another requested video by one of my students, some equations with fractions. So let me start off with 3/4 x equals 1/8. Okay, so we know when we go back to our simple equations that anytime that there's a number in front of a letter, that means that we're multiplying. So we use inverse operations, and we would be dividing both sides by 3/4. But when we divide fractions, we multiply by the reciprocal. So I'm going to flip this fraction and multiply by 4/3. Erase this. Okay, so cross cancel, we're left with x. Perfect. So if we multiplied by 4/3 over here, we have to multiply by 4/3 over here. I'm going to cross cancel. I'm going to make this a 1 because 4 divided by 4 is 1. 8 divided by 4 is 2. If I multiply across, I have 1. Multiply across, I have 6. So I got 1/6. So if I take, I have x equals 1/6. Now I'm going to plug it in. So I have 3/4 times 1/6. And I should get 1/8. So let's see if I do. Okay, first of all, I can cross cancel here. So I'm going to get 3 divided by 3 is 1. 6 divided by 3 is 2. 4 times 2 is 8. 1 times 1 is 1. That's the answer that I'm supposed to get. So I'm finished. Let's try one that has addition. Okay, I could have a problem that looks like this. 1/8 plus x equals 3/16. Okay, so 1/8 plus something gives me 3/16. So because I'm adding, I'm going to subtract 1/8 from both sides. So if I subtract 1/8 over here, I cross this off, and I'm going to subtract 1/8 from the other side as well. I can't do this because I don't have a common denominator. So I'm actually going to do 3/16 minus, I'm going to use 16 for my denominator. If I changed this by 2, I have to multiply the top by 2. So I'm going to get 3/16 minus 2/16, and I'm going to get 1/16. So I only have an x over here, so I have x equals 1/16. Now if I plug this back into my original problem, I would have 1/8 plus 1/16, and I should get 3/16. I can't add this, so I'm going to change this denominator to 16 because I know that's my common denominator. I multiplied the bottom by 2, so I multiply the numerator by 2. 2 plus 1 is 3. I keep my denominator, and I got 3/16, so I know that I'm correct. Okay, these are the ones that are a little bit trickier because we're used to using inverse operations. In this case, this one's a little different. 4/5 minus x equals 3/10. Okay, first of all, I do not have common denominators, and in this case, it makes more sense for me to change them to begin with. So I'm going to change this one over here. So from 4/5, I'm going to change that to 8/10. I doubled both of them. So now I have 8/10 minus something equals 3/10. So for some of my students, I break this down without the fraction, and I say 8 minus x equals 3. So they can see that you have to find something to subtract from 8. So in this case, we're actually going to subtract the 3 from the 8. So that's what we're going to do for this problem here. I'm not even going to draw a line down the middle because we're not going to use the inverse operation. We're actually going to do 8/10 minus 3/10, and we're going to get 5/10, or 1/2. So if I plug that back into my original problem looked like this. 4/5 minus, and I'm going to put 1/2 in here, equals 3/10. So I found x, and I'm going to put it in here. So if I have 4/5 and 1/2 and 3/10, I want to talk about tenths for all of this. So let's change. Change this to 8/10, multiplying by 2. I'm going to change this to 5/10 by multiplying by 5. And that should equal 3/10. 8 minus 5 equals 3. And then we keep the denominator. So I did all of the work, substituted in for x, and I have the correct answer.